And this time we have two parabolas. But again, substitution works well because you have the y by itself. So I can substitute in the x plus 2 squared minus 1 into equation 2, which was y equals x squared minus 4x minus 5. Now before I can combine my like terms, I have to do a little bit of algebra. The x plus 2 all squared, I have to multiply that out. X plus 2 times x plus 2 is x squared plus 4x plus 4. Make sure that you multiply and distribute all of that out. And now I want to collect my like terms, so I'm going to move everything over to one side. Which means I'm going to subtract my x squareds, which means they go away completely. Kind of nice. I'm going to add 4x to both sides. That'll be 8x. I'm going to add 5 to both sides. This will be 3 plus 5 plus 8 equals 0. Now I had made one side equal 0 because I thought it was a quadratic equation, but my x squareds all canceled. Now it's just a regular solving equation. I have to, all that work to move that 8 over, I'm going to have to move it back to the other side by subtracting 8 on both sides. Dividing by 8, and I get x equals -1. So there's only one x point where they intersect. And when x is equal to -1, I can use either equation to find out what y is. Some people plug it into both to double check that it works. So I'm going to plug it into the first equation. So when x equals -1, y is equal to -1 plus 2 squared. What was the first equation? -1. And this will be -1 plus 2 is 1, 1 squared is 1. I get 1, 0. So my solution is 1, 0. Just going to zoom this out a little bit. If you were trying to solve this one graphically, can you see that the first equation is in vertex form? We could graph that one quite easily because you can see that the vertex is at -2, -1. And it would open up. The second equation is not in vertex form. So we would either have to complete the square or factor it. Does it factor nicely? It does. Can you see that this one factors nicely to x minus 5, x plus 1? So I would have x-intercepts at 1 and 5. And if I know that, and I know that it opens up, vertex would have to be right in the middle, somewhere down here probably. And it looks like this. Now my graphing technique told me the same answer, -1, 0. But the problem with the graphing technique is I'm not 100% confident. Maybe they cross again, and I just can't see it. How could I be confident that they don't? You know, it's like a bit of hand waving, like, it looks like they don't, which is not a very strong mathematical argument when trying to convince someone. But the algebraic technique, if there was another answer, it would have shown up. So the algebra is often more powerful. Graphing, though, can sometimes be a quick way to find an answer. Sometimes it's not. Okay, questions for this one? Just number 7.